Okay, so in standard form, if they're not already, we would write them up in standard form. And then we're looking for the same coefficient. Once we find the same coefficient, all we're going to do is decide, do I want to add or subtract? If you look at problem 19, you could actually do either one. It's going to be totally what you think would be easier. So if I have x plus y is equal to 8 and x minus y, you all can hear me at home, right?
Yes, ma'am.
Equals 4. You probably remember those problems, those word problems, the sum of two numbers is and the difference is. All right. On here, everybody's coefficient is 1. Since x has the same coefficient and y has the same coefficient, you have a choice. Everybody? If you want to get rid of those x's and eliminate them, you're going to turn this into a subtraction problem. Because 1 minus 1 is 0, and we eliminate x, right? But if you want to get rid of the y's, then you're going to add. Because positive 1 plus negative 1 is 0. Okay? Same sign, you're going to add. Different signs, I have this absolutely backwards. Same sign, you're going to subtract. Different sign, you're going to add. You're looking to get that 0, right? I like adding better, so I try to go for the different signs, and you can change those signs if you want to. But right here, I've got positive 1y plus a negative 1y. They cancel each other out. I'm coming straight down and just adding the two equations together. 1x plus 1x plus 1x gives me 2x, and 8 plus 4 gives me 12. Now I have an equation I can solve because I've eliminated one variable. And I'm going to say dividing by 2, x is equal to 6. Okay, now I've got to plug in. I got to plug x in and find my y. My answer is a coordinate point. What I am looking for is if I were to graph these two lines, where would those two lines intersect each other? My answer is that coordinate point of intersection. So I have 6 plus y equals 8. All I did was take my 6 and plug it in for that x, right? So 6 plus y equals 8, and I'm going to subtract that 6 from both sides, and that gives me y is equal to 2. So what is my answer? X is 6, and y is 2. And let me throw a cautionary tale out there, guys. These are especially wicked on a multiple choice, because you know that 2, 6 is going to be on there as one of your wrong answers, right? So you got to kind of go back and check yourself a little bit once you get your answers. Okay, so this one was nice, easy. Everybody was ones. I'm going to look at problem 22. I have x plus 3y is 5 and 2x minus 3y negative 8. My x's have different coefficients, so I'm not going after them right now, but my y's have the same. My y's have that 3, right? So I'm going to go after the y's. One's positive, one negative, so I'm going to add them together. And that's going to give me 3x. 5 plus negative 8 gives me a negative 3. And x is equal to negative 1. Okay, again, I've got x. I'm going to plug it in. And where you plug it in is going to be completely up to you. Whichever one, do a little math in your head and decide whichever one you think is going to be easiest. So I have negative 1 plus 3y equals 5. I'm going to add that 1 to both sides. 3y is equal to 6. Dividing by that 3y equals 2. So my solution, negative 1 and 2. So let's go. Let me find one more like that before we move on to when we start manipulating them. Now, not too, pretty easy. Let's see what we get on that. Add or subtract? Right? Because those signs are different. So I would get Oh, and I was subtracting. So I would get 10x is equal to 21, yes? Now we got to divide that by 10, and x is equal to 21 over 10. Oh, this is going to be ugly. Why didn't y'all stop me? Did we get 21 over 10? All right. So 4 times 21 over 10 is going to be 42 over 5. Yes? Check my math, guys. Plus 3y equals 9. And 42 over 5. Let's go to a decimal. Is 8.4? Okay. So 8.4 plus 3y is equal to 9. Subtracting that 8.4. 3y is equal to 0.6. Dividing by 3, y is equal to 0.02. Just 0.2. 3? Okay. Yeah, that makes sense. So I have 21 over 10 and 1/5. So much for trying to do one more easy one before we get moving. All right, so when I move on to the next ones, like problem 24, let's go 25. Nobody's the same. 3x minus 6y equals 2, and 5x plus 4y equals 1. No? Nobody's the same. And you know what? 6 isn't a multiple of 4, and 5 isn't a multiple of 3. But I can use my distributive property and make them multiples. And again, I prefer to add, so I'm going to still go after my y's. So I'm going to take this entire equation, and I'm going to use this 4 and multiply everybody by that 4. I'm getting that 4 right from, and then I'm going to come down here and multiply everybody by 6. So now I have 12x minus 24y equals 8, and 30x plus 24y equals 6. All right, my 24y's, they're gone, right? And I get 42, not 32, is equal to 14. Boy, this section likes those fractions, doesn't it? All right, I'm going to divide by that 42. And it's not going to divide, but it will simplify. X is going to equal, all right, 12 times 1/3 minus 24y is equal to 8. If I break 12 into 3 equal portions, I'm going to get a 4 minus 24y equals 8. And getting rid of that 4, negative 24y equals 4. Dividing by that negative 24, y is going to equal a negative 1/6. 1/3, negative 1/6. Recalling them, maybe hearing that word elimination isn't really bringing them back, but do you remember doing these in Algebra 1 and Algebra 2? Most definitely a couple of these on your upcoming unit test, and I have always seen at least one of these on the final exam. Troy writes your final exam for you, but I always see one of these. Okay. All right, so we're going to go back then to chapter 6. Unless, do I have any questions on these? We need to do another one. Okay. All right, when I am looking at a logarithm, what I am looking at, guys, is a inverse of an exponent. Okay, so like I know two to the third equals 8, right? 2 times 2 times 2 gives me an 8. All right, well, the logarithm gives me is when I'm trying to find out what that exponent is. A logarithm would say log base 2 of 8 is equal to 3. The solution to any logarithm or natural log, log or ln, is that exponent. Okay, we still have our base, we have our solution, and the exponent is what I'm looking for on the outside. So like on a number 11, they have 3 to the second is equal to 9. As a logarithm, log base 3, whatever this is in my subscript, of 9 equals 2. What it equals to is that exponent. What would you write if y'all have a to the second is equal to 1.6? What would that look like as a logarithm? So I'm going to have my subscript is going to be the a, that's the base, of 1.6 is equal to 2. If I go back the other way, so if I have What is that in exponential form? Who's my base? Solution, exponent. So you would have a to the sixth is equal to 3. When you have no base, let's say I just have, if it's ln, the base is e. If it's log, the base is 10. If they do not write a base there, just like that 1 in front of an x, this is going to be e to the fourth is equal to 10, and 10 to the fourth is equal to, whoops, sorry, I'm looking at the wrong. Couple of those properties that we talked about on what if I have, I'm not sure if I did this one in class or not, what if I have, this is the page that I gave out Monday night. There's some down up here if you want them. What do I need to do? What do I need to have in order to solve this equation? When I had my properties of exponents, we always had to do, all of them were always based on having the same base, right? So I have to have the same base here. Remember, this is just the inverse of an exponent. So a lot of the rules are just going to apply right along that we did with those exponents. I need to make that 27 into a 3, right? So I got to think about how could I break 27 down? And now it's going to be 3 to the third. So if I have 3 to the x squared minus 7, then I'm going to have 3 to the third to the 2x. So if I'm looking at those properties, what do I do with that 3 to the third to the 2x? When I have a power raised to a power, what do you do with those exponents? Multiply. So I have 3 to the x squared minus 7 equals 3 to the 6x. Now remember, if my bases are the same, then my exponents are the same. So that gives me that x squared minus 7 is equal to 6x. And I'm going to say x squared minus 6x minus 7 equals 0. And then factor it. So what can I multiply to get a -7 and add up to get a -6? Y'all are just way too talkative. X minus 7 and x plus 1. So my solution set is going to be 7 and -1. One more of these before we go to our solving these equations. So how about 8 -x plus 11, 16 to the 2x. Gonna have to do some distributing on this one. But it is linear. Eight is 2 to the third. 16 is 2 to the fourth. So again, when I have one power raised to another, I need to multiply them. So 3 times -x plus 11 and 4 times 2x. If those bases are the same, the exponents are the same. So I've got -3x minus 33 plus 33 equals 8x. I'm going to add that 3x to both sides. 33 is equal to 11x. And x equals to 3, right? It comes down to, once you get it in its right format, you're just right back down to having equations from chapter 1. Okay, so we have these equations to solve, and then we have the log and exponential equations to solve. I don't know if you wrote these down the other night. What do we do with that? Well, Sam, remember those exponential properties? One that we've already looked at tonight, a to the n times m. What if I wrote this? What number would x have to be? If a stays a, 1, right? X has to equal 1. Okay, what about a to the x is equal to, sorry. What's the only exponent that's going to give me a 1 out here? Regardless of what A is. A could be any number in the world. X has to equal 0, right? Okay, so when we're looking at these, when we find the exact value, I'm going to set each of these equal to X. Then I'm going to use my exponential properties, rewrite them as exponents. So if I have log base 2 of 1 is equal to X, what would that look like as an exponential expression or equation instead of a log? Base, exponent, solution. 2 to the X equals 1. Just looked at that a second ago. If 2 to the X is equal to the 1, then X has to equal a 0, right? Eight of 8 equals X. What would that look like as an exponent? So what does X have to be? Okay. So what if we are getting away from those and I have as an exponent, I have 7 to the X is equal to 49. Now I'm right back where we were talking about just a minute ago. I got to get my bases the same, right? So I can rewrite 49 as 7 to the second power. So I have 7 to the X is equal to 7 to the second power. So X is equal to 2. Make sense? How about 32 here? I have So I have 1/3 to the X is equal to 9. Well, I know that 9 is 3 to the second. So 1/3 to the X is equal to 3 to the second. But I need to get that 3 into a 1/3. What do I do to exponents to get an inverse? What's going to help me? What allows me to flip that exponent over? or that 3 over. Make it a negative 1/3 to the x is equal to 1/3 to the negative 2. Remember, negative exponents say inverse. And now it's going to give me x is equal to a negative 2. What is my base here on problem 34? I have when it's a log, L-O-G, what's the base, the given base, if nothing else is written there, what is your calculator going to use? 10, right? There's a 10 here. So I have 10 to the x is equal to the cubed root of 100. So here we got to pull in some other past Algebra 1 business. How can I write the cubed root of 100 with an exponent instead of, do you write anything, any radical? As an exponent instead of a radical. This would be a to the 1/2, right? If I had the square root of a to the 5th, that would be a to the 5/2. Yes? Okay. So this is going to be 10 to the x is equal to 100 to the 1/3. I've got to make those bases the same. So instead of writing 100, I'm going to write Now what do I do when I have two exponents out there? That's a multiply. So I have 10 to the x is equal to 10 to the 2/3. So x is equal to 2/3. Okay? Let's try one more of those. We'll look at problem, how about 35? So how would I change that square root of 2 to the x? What do I get when I multiply 1/2 times x? Since my bases are the same, I can set my exponents equal to each other, times that 2, and x is equal to 4. Okay, that's all I got. So if you have questions, you want to work on stuff, I'm here. I'm not going anywhere. So you can work on stuff. If you're good to go, you're good to go. We have 2 more instructional nights, a test night, and then a review night for your final exam. Anybody online questions?